Okay, now this is pretty epic. I finished my donut.c program. I finished rewriting it and I'm so proud of myself. This is insane. Um, I've been working on this for like the past month, I guess, as like a semi project kind of, you could say, like you could say. And yeah, I learned a lot of stuff. What I did basically was go through. If you don't know what this is, this is by, it was coded by a famous programmer, Andy Salone, yeah. Um, it just renders a 3D spinning donut on your terminal. And I was like, okay, that's cool, that looks interesting. What to do? Let's try to rewrite it. Let's go through the math and see if we can um, write our own version of it, and maybe also change it, make a cube, make a pyramid out of it. In the future, maybe I will add also more shapes, depending on how I will feel about it. But yeah, and I tried not to look at the source code and just make it my own, like go on my own, like go through the um, through the math, and yeah. Although at the beginning I was looking at the obfuscated version of its source code, so yeah, and also at the end I cheated a bit. I took a glance at the formula to calculate the luminance of every point on the shape. So yeah, I learned a lot like about the rotation matrices, how they work, how you calculate them, whatever. So how to rotate a vector by x degrees in the 3D or 2D space. I learned like how to keep plot a circle. Yeah, I guess that's the term. Project a point from 3D space to 2D space. And then much more, you could say. Like also, yeah, how to calculate the lightning. And yeah. So like if I try and showcase what I did now. The first one was the donut one, which is this. It has a bug, like it rotates and moves at the same time. I will try to fix it in the future, but yeah, I'm satisfied with this. Yeah, that's it. Then you have the cube, which was my second like kind of challenge. Change the code, make it look like it projects a cube instead of a donut. It's kind of buggy because like you can see through it, you can see all the pixels, the points inside, and also their illumination. Not sure yet why it does that. I should take a look and maybe like take a look at how it stores the data inside of the frame buffer. The z-axis buffer. But yeah, okay. And the third one, which I finished today, is the pyramid, and it's basically the same as the donut. I thought it was gonna be hard, but it's actually just sorry, I meant cube. I thought it was gonna be hard, but like when you think about it, it's basically just a cube. But depending on on which like y position you are, you wanna cut that amount of x and z value from the width and height. Yeah. So like if you're on top, you wanna take the whole length of x and z and remove this many pixels or points, you want to say. And if you're at the bottom, you want to remove 0. If you are at the half, you want to remove the half. If you are, I don't know, at 1/3, you want to remove 1/3. That's how it works. It's nothing complex. It's just a kind of modified for loop if you take a look at it. Yeah. In either case, the code is available on GitHub. I uploaded it so you can take a look at it, maybe try and fix your my bugs. I will do it as well probably in the future, but for now I guess you can do it and maybe push to the repo. Request a push, yeah. And yeah, maybe also try making new shapes. I don't know. making an actual object, like a table. I don't know how you would do that, but like I guess if you think about it, it's just like multiple shapes, like stretched cubes, and basically just stretched cubes. It's like you're doing it in Blender. You just start from a cube usually and just like work your way through it. And yeah, that's how I guess it will be done. Or I mean, there are probably smarter ways, but like yeah, that's my way. That's my way at the moment, like how I'm predicting I will start. Kind of solving and going through the problem. So yeah, I'm gonna explain now the math behind it, not actually the math, but like how the program works. Specifically the donut.c one, or maybe actually yeah, let's do the cube because it's the easiest one, I guess. Although it's less commented than the donut. So yeah, it's actually nothing really, not that like hard you could say, even though it looks. It's basically just you initialize a buffer I mean array, here, which you will then output. You have like a character array, which will be basically your characters in the output, something like this, then this, the first, the second, the third, the fourth, the fifth, the sixth, the seventh, whatever line. Okay, every 200 characters there will be a character for line break, and there will be 100 sections of those line breaks, and like to signify each line. So then you say the dimensions of the cube, okay, 10, 10, 10, and then you calculate the starting position. I did it by just saying start at the negative half of the x dimension. So like start at -5 x, at the -5 y, at the -5 z, and go to the 10x, 10y, 10z. So yeah, if you can imagine it in your brain, I guess it's gonna be a lot easier to imagine it and why I did it. So yeah, you can try also drawing it if it's too hard, I guess. Then you have the rotation angles, which is just a variable signifying the angle, which we'll then use to rotate the cube, and a updater which will update the angle by that value. Keep in mind that these angles are are not in degrees. So if you take a look at the manual page for like sin, it's inside of the math library, of course. And yeah, here's the description. Like this function returns the sine of x, where x is given in radians. So yeah, then you have manual page for cosine, and yeah, you can take a look at them. Then yeah, we just go for every pixel, for every point at 0, 0, 0 till the size. Then you calculate the point's location, I guess, starting at the start of x plus the index, and then you just use some rotation matrices to rotate the point around in 3D space. In this case, I rotated by an angle of A, which will update over time, around the x-axis, and by an angle B, which will update over time, around the y-axis. Then there's some like magic here. I don't know. This is just me experimenting, like what works and what doesn't work. I'm not sure why it works. Like I am. It was because like you have to distance the object from the viewer to make it more clear, like how, like to make the object clearer, you could say. Then you calculate this, which is 1 over z. It's then later used in the to like calculate the illumination of the object. And here you project it. You like use a a formula to calculate, to plot it to a 2D point on the terminal, and then you calculate its position given the size of the array, and then you calculate it, the lightning of the point by using a unit vector. So like you remove the useless, the length of the whole vector. You just say it's a unit vector. In this case, it's not actually a unit vector because it's a length of 2, but that was just my mistake. In either case, I tried to remove it, like to actually do this 0.5, 0.5, and 0.5, but that didn't change a lot. So yeah, 2, 1, 1, 1. So if we take a look at it now, it's running the donut. I have to fix this. Cube. Make. You can see that it's basically the same thing. So yeah. After that, what it does, there. Okay. After that, yeah, okay, it just performs the same rotation to get to the spot of the point, and then uses a dot product to calculate its illumination. If the illumination is below 0, set it to 0, because we want to plot the whole cube. Say for example, if this angle is completely dark, if this point is completely dark here, it will be below 0, and like we still want to plot it. Show it, because we want to show the whole cube. So no matter how dark it is, it's always gonna show the lowest value. It's not gonna go under. Below. So you just here use the 1/z to kind of check whether they're already plotted. Set points z value is greater than the current one, and if it is, if it's not, we're gonna plot it there. So if the point, the new point we're gonna insert into the array, into the specific position, has a higher value of z, a lower in this case, because lower means closer to us. What we're gonna do is we're gonna plot it, well, because it's closer to us. If you have a calculator in front of you and something behind it, you will not see the thing because the light doesn't pass through. So yeah, and then multiply it with 8, the illumination. In case it's higher, just put it to 11. Then the limit of the characters that we have, and then just see, check which one it is, and set the current OOZ value to the position of the Z buffer. Then here's just some magic to output the whole output buffer, which is like if we are at the end of the line, it's gonna output a ending line character, else it's gonna just output whatever is in the output buffer at the current position. Then it's gonna sleep for some microseconds, yeah, and it's gonna clear the screen and update the angles. And that's the whole, I guess, explanation behind the cube. I'm not sure how good of an explanation that was, but yeah, I guess I tried. Then there's the donut, okay, of course, and the pyramid. Pyramid, as we said, is basically the same. It's just a cube with by slicing this much of the x length and the z length, depending on how high or how low the current y value is. Then you have the donut one, which is basically just the same, but using having a circle and spinning it around the y axis. If you're more interested in how the donut works, there's an article from Andy Sloan, of course. Andy Salone, yeah. Yeah, basically you can imagine it like this. You have a circle, you start at R2 with a radius of R1, and then spin it around the y-axis. And then rotate the whole thing to make it rotate, of course. And yeah, that's how I made it, I guess. There was a lot of trial and error, I guess. I myself am not sure how some of the parts of the donut.c still work. I have to dig into it, but for the most part, like for the 95% of the whole code, I'm pretty sure I know how it works. So yeah, that was it. Hope it was informative.